Even though Industry 4.0 has entered another decade, the subject is still stirring interest, being implemented in more and more sectors of the economy. Therefore, it is not surprising that solutions based on Industry 4.0 are implemented in such a dynamic sector as pharmaceutics. There are some obstacles in development Industry 4.0 for pharmaceutics. The report Accenture, 2018 mentions high cost of digital technology obsolescence, insufficient data security and trust, shortage of digital skills, unable to leverage technology combinations, unable to draw on innovative ideas within the ecosystem. If so, is it worth bringing Industry 4.0 focused technologies to pharmaceutics? Is it profitable, and if yes, therefore to what extent? This brief paper tries to answer such questions. The paper presents a conceptual model of transformation of traditional, classic, pharmaceutical factory into a smart one, with application of Industry 4.0 solutions. The proposed solutions allow to reduce production costs while increasing its efficiency thanks to robots, AI solutions, sensors, and RFID technology. From the beginning of humanity, society has been striving to improve everyday life in all its areas. One of them is technological development that is constantly changing. Nowadays, billions of people use mobile devices, which gives a great opportunity to process and collect information. New production technologies radically change the working conditions and lifestyle of society. The fourth revolution called Industry 4.0 inches is taking shape before our eyes, concerning the development of advanced information technologies, communication and information technologies, as well as virtualization. With the advancement of the fourth industrial revolution, new business models are being shaped to revolutionize production, transport and delivery systems. For the proper functioning of enterprises, an adequate flow of data is needed, as well as their proper collection. It enables better production planning, product lifecycle management and resource management. From year to year, the amount of data grows dramatically due to the continuous development of enterprises. Owing to the digitization of data handling processes, it is possible to use them faster and more efficiently, allowing for increased production efficiency and reduction of costs. Mobile connectivity and data transmission made it possible to connect devices with each other in order to react faster and more efficiently to situations, as well as to monitor production processes. In the face of Industry 4.0, the automation and robotization of production processes is also progressing. This allows us to increase efficiency, reduce production costs, and increase safety on production lines. Firstly, it is important to present the manufacturing operations in the factory. There are 5 production lines in the company, which manufacture 750,000 drug packages per day. The technological process is as follows. The production line receives pills and film for blister packing, transparent packaging. Further, the pills are wrapped in blister packs using vacuum and covered with aluminum foil. The blister packs are cut and packed into appropriate wrappings. Next, the finished packages are inserted in cartons, bulk packaging, put together in the form of a pallet loading unit to be transported to a warehouse. There are 130 employees working on 5 production lines. Such data related to blister factory was a starting set for the research applied and therefore to the methodology of this study. The necessary expenditures and operating costs for both the classic factory and the smart one were calculated. Afterwards, the certain parameters together with these expenditures and costs were compared according to the comparative method. This allowed for a relevant discussion and presentation of the conclusions of the research. The first element of a smart factory are Internet of Things, IoT, solutions. In this case, there are 2 possibilities for introducing this technology. The first option is to create local server infrastructure, whereas the second option is to use cloud-based data storage and processing solutions. Microsoft Azure was proposed as a platform offering data storage services on virtual machines. Tables 1 and 2 show detailed costs for both solutions over 5 years. In the case of the Microsoft Azure platform, the costs for software, energy, and computing instances in the data center do not occur, and the number of hours of work of the IT department can be reduced by about 55% due to lack of need to supervise and maintain local devices. A comparative analysis of local infrastructure and cloud solutions showed that in the case of using the Microsoft Azure platform, €67,562.57 for 5 years can be saved, which is why this solution was chosen to implement the smart factory model. The IoT technology will be applied to collect data from objects with sensors. For this purpose, solutions offered by Microsoft Azure were selected. The first element is the Azure IoT Hub function responsible for communication between the IoT application and devices equipped with sensors. The software collects data from devices and saves them in the cloud. Another element is the Azure Digital Twins platform, which enables to develop digital twins, including places, processes, and people. The next element of the system is Azure Time Series Insights, which transforms the data collected from sensors into practical information. Windows 10 IoT Core Services is a function responsible for monitoring the health of devices, as well as for managing updates of these devices and the operating system. The final component of the IoT system is the Azure Analysis Services feature. It is a service responsible for modeling and combining data from multiple sources in a tabular data model. Summary of applied IT solutions of the IoT are given in Table 3. Next element of the smart factory are robots. In this case, it will be cobots, collaborative robots, and autonomous forklifts. They are responsible for carrying out activities that were previously the responsibility of employees. The role of employees delivering tablets and wrapping foil to the production line and collecting ready pallet load units can be replaced by BAL IOMIC 10-15 robot autonomous forklifts. The robot identifies the position of the pallet load units located in the warehouse itself and transports the pallet load units to the indicated location. Its maximum lifting capacity is 1,500 kilograms, and the maximum height at which it can lift a loaded pallet load unit is 5,076 millimeters. Each production line should be equipped with 3 such forklifts. The price of one vehicle is €68,908.40. Function of quality control employees can be performed by the Universal Robots R3E Cobot, which will perform quality control by the Shining 3D Inscan Pro 2X 3D scanner. Cost of this Cobot is €2993.21, and price of the 3D scanner is approximately €5,381.29. Functions of employees to unfold cartons, pack blisters, pack finished boxes into boxes and stick labels can also be replaced with the Universal Robots R3E Cobot. The Universal Robots R10E Cobot will be used to stack the cartons on the pallet. It was chosen due to the weight of the cartons with packages, as well as its long range. Its maximum load capacity is 10 kilograms. Cost of this Cobot is €3,901.36. Table 4 presents a summary of the expenses that must be incurred when equipping 5 production lines with robots and cobots. The following employees will be required to operate the intelligent production lines. 2 employees will be needed to control 10 forklifts delivering tablets and wrapping foil to the production line. 1 qualified employee will be needed to supervise the cobots on the production line. 1 employee will be needed to supervise the forklifts collecting goods from the production line and delivering them to the warehouse. 1 employee will be needed to move tablets and foil delivered by our autonomous forklift to the production line. 1 employee per production line will be needed to refill the pallet load units for a new one. Another element of the smart factory are sensors that collect the parameters of technical devices and send them to the IoT system for real-time analysis. The production line should be equipped with additional sensors to detect irregularities. In the place where tablets and foil are delivered, the presence of foil in which tablets are packed should be checked. The Panasonic PM-R25 photoelectric sensor was used for this purpose. The Panasonic GXL8 FU inductive sensor should be used in the area where the blisters are covered with aluminum foil. It will detect the presence or absence of aluminum foil. The number of stacked blisters should be monitored. Panasonic FX-301 fiber optic sensor was used for this operation. In the place where the blisters are packed in cartons, it should be checked if carton has been unfolded correctly and that the cobot has put them in the right place. For this purpose, the Panasonic DP002P pressure sensor will be used. However, to verify that the cobot has put the packaging in the right place, the Panasonic 6101P color sensor will be used. Table 6 lists the purchases of all sensors needed for the 5 production lines. In order to control products manufactured on production lines, each pallet will be labeled with an RFID label. 65 labels are required to mark all pallets in one day. It means that 117,000 such labels will be used over a 5-year period. To read the information on the label, a terminal with an RFID module or a stationary reader is necessary. RFID readers are connected to software for managing and tracking information collected by them from labels. 2 qualified persons are required to operate the RFID system. List of RFID devices and their costs are given in Table 7. Total investment costs include one-time costs of purchasing machinery and equipment, as well as cyclical costs such as salaries for employees or subscriptions for cloud solutions. Thanks to the introduction of robots to production lines, the number of manufactured products can increase by 30%. It means that the factory can now produce 975,000 packages a day. This is a value greater by 225,000 packages. Thanks to the introduction of robots and IT systems, profit after deduction of manufacturing costs increased by 436,674,621, €74 within 5 years. In order to verify the validity of the proposed solution, a comparative analysis of the factory was carried out before and after the implementation of intelligent solutions. The analysis showed that using the solutions of the Fourth Industrial Revolution, the production efficiency on production lines increases by 30% due to their accuracy and repeatability, which also translates into the generated profits. And the expenditure is reduced by approximately 8% in relation to its classical approach. The number of employees has been reduced so that the human error factor has been kept to a minimum. By introducing sensors to monitor and detect possible faults and threats on the production line, the level of safety has been increased. On the other hand, the integration of technological processes reduces the used amount of energy. Owing to this, also the emission of carbon dioxide to the environment decreases. In summary, innovations and solutions related to Industry 4.0 have a positive impact on efficiency, work safety and environment, ecology. Moreover, factories are able to generate higher profits with reduced financial outlays. Thank you for your attention.